Let's talk about Christopher Nolan's Interstellar. It took us on this incredible journey to the edge of black holes, a place where time itself gets all twisted and warped. But how much of that was actually real? Well, it turns out a surprising amount of it was. We're going to dive deep into the brilliant science behind the movie, and our guide is the Nobel Prize-winning physicist who was really the secret ingredient in the whole thing, Kip Thorne.
You see, what makes Interstellar so special isn't just its scale, but where it came from. This wasn't just a director consulting a scientist. It was a true collaboration. As Christopher Nolan himself said, Kip Thorne wasn't there to be the science police. No, he was a storyteller, someone who is genuinely passionate about sharing the, quote, crazy truths of our universe with all of us.
So that's the big question, right? How did they pull it off? All that mind-bending stuff in the film, from those terrifying planet-sized waves to losing years in the span of an hour, how much of that is actually based in reality? Well, let's unpack the physics together. Okay, so here's our game plan. We're going to start with how a world-class scientist wound up in Hollywood in the first place. Then we'll get into the actual rule book that the entire story had to follow. After that, we'll dissect the anatomy of the film's real star, the black hole Gargantua, and finally, we'll see how the team managed to film something that's literally impossible to see. Believe it or not, the story of Interstellar actually started way back in 2005. A producer, Linda Obst, went to our good friend, who just happened to be the physicist Kip Thorne, and she had this amazing idea for a movie. Her vision? To make a huge blockbuster that was grounded in real, honest-to-goodness, cutting-edge science right from the very beginning.
So when Thorne eventually sat down with Steven Spielberg and later Christopher Nolan, he laid down two fundamental rules. And these rules became like the scientific constitution for the entire film. Rule number one, nothing in the movie could violate the firmly established laws of physics. And rule number two, any wild ideas, any speculation had to come from real, plausible science. This is the framework that makes Interstellar so much more than just science fantasy.
All right, so to play by those rules, the filmmakers needed a proper physics toolkit. And what's really important to get is that our universe kind of runs on two different sets of laws. On one hand, you've got Newtonian physics. That's the stuff of our daily lives, you know, how a ball falls or how a plane flies. But Interstellar? Oh, it plays in a totally different sandbox. It operates in the world of Einstein's relativistic laws, which are all about extreme gravity, black holes, and warped spacetime. And that is where things get really, really weird. And super interesting. So to navigate all this weirdness, Thorne came up with this brilliant system. He sorted all the science in the film into three simple categories: truth, educated guess, and speculation. This is the secret to how the movie could be so scientifically accurate while still telling a totally thrilling story. Let me show you how it works.
Okay, so that stunning, mind-bending way the black hole bends light, that's a scientific truth. It's based directly on Einstein's equations. What about the global blight that's killing all the crops on Earth? That's an educated guess. Biologists say it's possible, but probably not going to happen. And those weird gravitational anomalies messing with Cooper's compass at the beginning? Pure speculation, an idea that comes from some wild theories about higher dimensions.
Now, let's get to the biggest, baddest, most mysterious character in the entire film, the black hole, Gargantua. We all think we know what a black hole is, right? But what is it really made of?
You'd probably think it's made of some kind of super-duper dense matter, something crushed down into a tiny, tiny point. But the real answer, according to Thorne and Einstein, well, it's a whole lot stranger than that.
Get this. A black hole is made of warped space and warped time. That's it. There's no stuff inside. The energy from its own warping is so intense that it actually holds itself together. It's like a self-sustaining vortex in the very fabric of the universe. Wild, right? And this brings us to the famous event horizon. Now, this isn't a physical surface you could, touch. It's the point of no return. It is the boundary where time itself, from our perspective on the outside, slows down to a complete and total stop. That infinitely warped time is what creates the infinite gravity.
So if that's the basic blueprint for a black hole, how did the filmmakers build their specific one, Gargantua? How did they give it those terrifying, dramatic properties we see in the movie?
Well, the physicist John Wheeler once famously said, a black hole has no hair. And what he meant by that is that these incredibly complex things can be completely described by just two numbers, their mass and their spin. That's it. Everything else about them, their size, their gravity, their effect on time, all of it flows from just those two little numbers. So let's start with Gargantua's mass. Kip Thorne calculated it needed to be 100 million times the mass of our sun. 100 million. And this wasn't just a random number. It had to be that massive to keep the insane tidal forces from ripping Miller's planet and our heroes to shreds.
All right, now for the spin. And this is a great little behind-the-scenes story. The most famous bit of science in the whole movie, that crazy time slippage, 1 hour equals 7 years, that was a creative demand from Christopher Nolan. He told Thorne it was completely non-negotiable. So Thorne's job was to figure out, okay, how fast does a black hole have to spin for that to be true?
The answer? It had to spin unbelievably, ridiculously fast. We're talking right up to the absolute speed limit allowed by the laws of physics, just 1 part in 100 trillion shy of the max. Any faster, and the event horizon itself would just vanish. So that one creative demand from the director ended up defining the single most important property of the movie's star.
Okay, so they've designed this monster. They know its mass, they know its spin. But how in the world do you actually show it on screen? This was maybe the film's biggest scientific challenge, creating a truly accurate picture of an object nobody had ever actually seen before.
The key to the whole thing is a phenomenon called gravitational lensing. You see, the black hole itself is invisible, but its insane gravity acts like a giant lens in space. It bends and distorts the light from all the stars and gas behind it. So what we're actually seeing isn't the hole. It's the hole's shadow projected against that warped backdrop.
And to bring this to life, they had to invent a whole new process. First, Kip Thorne himself derived all the complex equations needed from Einstein's laws. Then, the amazing visual effects team at a company called Double Negative wrote brand new software to actually render those equations. And finally, the artists came in and layered on the beautiful accretion disk and the starry background to create those breathtaking images.
And the result was just astonishing. Even for Kip Thorne, the man whose life's work this was, he said he was ecstatic. For the first time ever, a scientist was seeing his own theories visualized, not just accurately, but beautifully. It was this perfect marriage of pure scientific discovery and cinematic magic.
And really, that's the ultimate punchline. Interstellar became the first Hollywood movie in history to get a black hole right. So right, in fact, that when astronomers finally captured the first real image of a black hole in 2019, the whole world was blown away by how similar it looked to what Interstellar showed us years earlier, a vision created not with a telescope, but with pure math.
In the end, Kip Thorne's biggest hope was that the movie would just make people curious. He wanted all of us to puzzle over these huge ideas and maybe, just maybe, have one of those incredible eureka moments of our own. So I'll leave you with this. What puzzle from this film, or from our incredible universe, is going to lead you to yours?